Okay, use graphical evidence and known area facts to find the integral from 0 to 2 of 2x plus 1 dx. Another way of thinking about this integral sign is kind of like an S that's been sort of stretched. This was some, if you think of integral as summation, summation, and you think of this dx as a little width, and this is your f of x, so it's the sum of all the f of x times dx. So basically, if I draw 2x plus 1, so that's quite a nice function. It's a nice linear graph. It has a y-intercept of 1 and it has a gradient of 2, so it goes along 1 and up 2, along 1 and up 2. So probably something like that. So that is f of x equals 2x plus 1, that's something like that. So I'm interested in the values between 0 and 2, so say that could be 0 there, say 1 might be over here and 2 might be there. So there's the line 2. Now, when I talk about this summation, basically, if what I'm interested in is summing all the values of f of x between 0 and 2. So what you're effectively doing is you're getting all these little values here and adding them up all the way. If we keep going and going and going, eventually, if the pen can handle it, you end up with the whole area. Now, these strips, they're supposed to go straight down, and if you just think about one of the strips, it could be modelled as a rectangle with a really, really small width, so we can call the width dx. Now what that is, it's an extremely small number, but it isn't infinitely small, it is finitely small. And then the height of that rectangle is your f of x at that point, whatever x is, because as x changes, so this might be a strip from maybe over here. If x was over here, then suddenly you've got a much smaller f of x. But whatever it is, it's f of x, or sometimes you call it f of xi. But basically what this does, it sums, we want the sum of all the heights of these little rectangles, tiny little rectangles stacked alongside each other. But when it says use graphical evidence and known area facts to find, well, this shape is a trapezium. You can see you've got two parallel sides here and here. The height of the trapezium is 2. This is 1, so the small base, one of the parallel sides is 1, sometimes called small base and big base, it's the parallel sides. This here is whatever 2x plus 1 when x is 2, so it's 2 times 2 plus 1 is 5. So this shape here is a trapezium with parallel sides of 1 and 5 and a height, or a perpendicular height of 2. So the area of that, so area equals half the sum of the parallel sides, so half a plus b, 1 plus 5, times 2. Well, 1 plus 5 is 6, or 6 times 2 and then divided by 2 is just going to get you back to 6. So a equals 6 units squared. So all these little lines, if we add them all up with infinitely small widths, their combined area, because they do have area, because the strip does have this very, very small width, it would be 6 units squared in total.